So tomorrow is the physics test, so I decided to make a small revision for grade 11 advanced students. So let's start. Which of the following is not a fundamental force? So here we have four options. As you know, four fundamental forces are the gravitational force, electromagnetic force, strong and weak nuclear force. Okay, so the friction force is the wrong option here in this case. Next. So, what force is responsible for holding the moon in orbit around the Earth? So, of course, this is one of the easiest questions. It's not the drag force, it's not contact force, which is related to the friction. Tension force is related to a cable or a string. So, of course, here in this case, the gravitational force is responsible for holding the moon or orbiting the moon around the Earth. We continue with question 3. Which of the following situations can be explained by Newton's third law? So here we have four options, four statements. Newton's third law is about action and reaction. In the first example, when a man fires a gun, of course the gun will go back, or we say it recoil. It will recoil, means the gun will move back. So the bullet is moving forward, but the gun is moving backward, and that's what we mean by Newton's third law. The second statement is about Newton's second law, which is not the case here. It's talking about the force and acceleration. So it's Newton's second law. The other two options, third is about free fall, and the last one is about Newton's first law, because the speed is constant. Here we continue with question 4. We have 2 points P and Q, two coordinates. So how to calculate the coordinates of a vector PQ? So always we start with the last point. So we start with the coordinate of the Q, which is the last point, minus the coordinates of the first point, which is P here in this case. So we do the calculation. So we got from the first one -7, -15, and -4, which is associated with option 1. So we continue here with question 5. We have a graph asking for the greatest acceleration. So from chapter 1, we should know that when we have a great acceleration means that we have the greatest slope. Here in this velocity time graph, you can see, of course, okay, let's start by eliminating some options. So B and F are not correct. Why? Because you can see here the slope is straight line. Okay, there is no slope here, B and F. So of course B and F are wrong. So we still have C and A. We need to choose between them. So we need to compare the line A and line C. If you zoom in or look into the graph, you can see that this line on C has a greater slope because the line is little steeper than in A. So the acceleration here in this phase is greater. So C is the correct answer. So we continue here. A projectile is launched from an unknown initial velocity of 30 degrees from the horizontal, and that's the picture. So we have a projectile asking which of the following statements is true. So here we need to compare, because it's a motion in two dimensions, x and y. So of course the velocity vector will be divided into two, vx and vy. So vx, you can tell here from this picture, vx is the adjacent side. So we need to use the cosine function. Vy is the opposite side here, this one, to the angle. So we need to use here in this case the sine. So by doing a simple calculation on by doing the calculation, you can try that cosine 30 is equal to 0.89, but sine 30 is equal to 0.45. So of course the x component here is the greatest. Okay, so the first statement is the correct one. So we continue. Which of the following is not true regarding the Earth gravitational force? So we have four options here. I have the only one, but I still remember some of the options. Of course, force is measured in newtons. Yes, that's true. So, but here they are asking for not true. So the all statements are correct except of one. Option B is correct. Let's go to option C. The gravity force is toward the center of the earth. Yes, that's always. The gravity force is always to the center of the earth. So B and C are correct, and that they are not the answer in this case. Its magnitude is equal to the gravitational force. So here they're asking or describing the force of gravity as equal to the mass, and that's wrong. And A is the answer here in this question. We continue. The position of an object is given by the equation. Here is the equation. Okay, but they ask for the acceleration. So how to go from the distance to the acceleration? Of course, we need to derivate. We need to derivate twice. First, derivate the distance to get the velocity, and then from velocity to get the acceleration. So here is the function 3t squared plus 1.5t plus 4.5. By doing the derivative, always the power should be minus 1. So here t to the power of 2 becomes t to the power of 1. But no need to write t to the power of 1. And we need to multiply the power by the coefficient. Here in this case, 3 multiplied by 2, it's 6t plus 1.5. We still need to derivate one more time to get the acceleration. 60 plus 1.5, its derivative is 6. So 6 meters per second square is the correct answer. We continue. A particle moves along the x-axis with a non-constant acceleration described by a equal 12t. So you always need to remember the ladder here. Okay, so here in this case we have the acceleration, but we need to go up to reach the distance. So we need to integrate twice. A equal 12t. In the integral, it's opposite to the derivative. So for the power, we need to add 1. Do you remember in the previous question? We subtract 1 from the power. Here we need to add 1 to the power and then divide by the coefficient. So 12t becomes 12t squared divided by 2. So it's 6 equal to 6t squared. And then we need to integrate one more time. 6t squared, it becomes 6 multiplied by t to the power of 3 t cubed divided by the same number of powers. So 6 over 3, which is 2 t cubed, and then we replace the time by 2 as it's asking here. T equal 2 seconds. So the answer is 16 meter. Continue. Here with the question 10. An object moves such that its position is given by the function. So that's the function. After 6 seconds, how fast and what direction? So asking for the magnitude of the speed and its direction. So it's two questions in one here. So we continue. So how to calculate the velocity from x? As I told you in the previous question, we need to derivate to get the velocity. So 3t squared minus 4t plus 1. We need to derivate it. So it's 3 multiplied by 2 multiplied by t to the power of 1 minus 4. Of course, the derivative of 1 is 0 because it's a constant. So equal 6t minus 4. So here in this question we have two times. First time is which is the t equal to 6 seconds, and the initial time where t is equal to 0. So let's calculate the velocity in both cases. So here velocity we replace, we substitute the time by 6 in the first case, and then we replace it by 0. That's the initial. So as you see, the speed is 32, but we don't know. We still have two options. Either 32 meter per second opposite the direction of its initial velocity, or with the direction of the initial velocity. So we still need to confirm whether opposite or with the direction of the initial velocity. So how to do that? We calculate the velocity at time equal to 0, and we can tell here, you can see that the velocity is negative. At time of 6 seconds it's positive, so both are opposite to each other, and option A is the correct answer. Here we are with question 11. A particle traveled 20 meters north for 20 minutes. So here one particle going north at the velocity of 20 meters per second time is 20 minutes, but of course we need to convert it to seconds. How? By multiplying by 60. Then reverse the direction, of course, means going south. And this time the velocity is 25 meters per second, and the time is 15, so we multiply it by 60. Okay, so that's the velocity and time converted to the units. Okay, so asking for the displacement. Of course, displacement is the difference between the distance traveled first and the distance traveled to the south. So we need to calculate the distance first when going north. So of course it's velocity multiplied by time for the first case and velocity multiplied by time for the second case. You can see the difference in the distance traveled. Here it's 24,000, here it's 22,500. So displacement, as you see here, it's the difference between the two. The difference means the negative. Okay, so the answer is 1,500 meter, which is 1.5 kilometer, and this is the correct answer. Here, asking for at what angle we have the maximum height h is equal to the range. Here we have a projectile. That's the case of a projectile. At what angle we should throw the ball? Then we have the range is equal to the height. Okay, at what condition or at what angle the range here is equal to the height? Of course, you should know that the angle 76 is the angle where h is equal to r. Continue to next question here. Which of the curves of the graph below represent the vertical component Vy? So here we have 1, 2, 3, 4, 5 options here, but four answers. We need to choose one of them. Which one is describing Vy? So that's the case of a projectile. As you see, Vy is changing every time the ball is moving. At first, Vy is too big and start to decline or start to lose its value. As you see here at the top, Vy is equal to 0. And then when the ball falls down again, okay, so the value of Vy start to regain its value. So it's small, big, and then bigger here. So the answer is AEY. So at first Vy was too big here, that's position, and then start to decline little by little, and then it becomes 0 at this point. So here is 0, Vy is equal to 0 relative to this point here at the top, in the middle. You see here it's in the middle. And then the Vy start to regain its value, but in the negative direction, -1, -2, -5, -10. It's gaining its value, its magnitude, but in the opposite direction. So E is the correct answer. Here we continue. A ball thrown off a 25-meter high cliff. Its initial velocity is 25 meters per second. So here we have a ball, and that's the cliff. The height of the cliff is 25 meters. We throw the ball upward, as they say, with an angle of 53 degrees. What is the maximum height relative to the ground? Maximum height relative to the ground. So to calculate the height, you should know the equation of V0 squared multiplied by sine squared, the angle, over 2 multiplied by the gravity. You replace the numbers. You have the initial velocity, which is 25, sine the angle, which is 53, multiplied by double the gravity. And the answer is 17.44. But still, we didn't finish yet. You need to remember to add the initial height, which is here in this case 25. So the total height, h total, is equal h0, which is the initial height 25, plus this height here, which is already calculated 17.44. And the answer is approximately 45 meters. We continue here. When an object of mass 18 kilogram is acted upon by a certain force, it moves with an acceleration of 6.4x plus 1.5y. What's the magnitude of the force? So acceleration and mass are given and asking for the force. So there is no other equation than Newton's second law, F equals ma. That's the equation that you need to apply here. M is given, but the only problem here is to calculate the acceleration. We have two values of the acceleration, one with respect to the x and the other is respect to the y. So how to calculate the total acceleration? By applying Pythagorean theorem, 6.4 square plus 1.55 square, which in the answer is 6.5. Then we replace it by the main equation here. So F equal the mass, which is 18, multiplied by the acceleration already calculated 6.5, and the answer is 118 Newton. Here is the other question, question 16. A river flows from west to east with a constant velocity of 1 meter per second. So here we have the water flowing from west to east. The boat was traveling to the north. This way was going up. The boat was going up to the north with a velocity of 2.4 meter. So of course the boat will deviate from its direction. It will change a little direction because of the force of the water. The water is pushing the boat. So the velocity of the boat will change and the direction as well. So we need to calculate the new velocity of the boat. So as I told you in the previous question, also we need to apply Pythagorean theorem because we have two values of velocity and we need to calculate the third one. So by applying Pythagorean theorem, we get the square root of 1 square plus 2.54 square, and the answer is 2.6 meter per second. So the boat is speeding up. We continue. On an airless planet, a ball is thrown downward from a height of 17 meter with initial velocity of 15 meter per second. So here we are throwing a ball from up to down. The height is 17 meter and the initial velocity is 15 meter per second. So the ball reached the ground after 1 second. So here they ask for the gravity. So what's the gravity here in this case? You need to apply this equation, the first equation in the kinematics, chapter 3, motion in one dimension. So delta y, because here the motion is respecting the y-axis, is moving parallel to the y-axis. So delta y equal v0t plus half gt squared. Delta y is given equal to 17 equal 15, the initial velocity multiplied by time by 1 second plus half gt squared. Then you replace or you arrange the equation and the gravity will be equal to 4 meters per second square on that planet. So if you drop a ball from a 50-meter tall building, so we have a tall building, how far is the ball from the ground after 2 seconds? So that it's similar to the previous question. A ball is thrown down, the initial height is 50 meters. We need to calculate the distance from the ground after 2 seconds. So it's similar to the previous question. We apply the same equation. Y final minus y initial or delta y equal v0t plus half gt squared. Here g in this case is given minus 9.8. So y initial is equal to 50. v0 it's equal to 0y because of this word drop. Drop means no initial velocity, which is 0 plus half g minus 9.8 and time 2 seconds. You arrange the equation and the answer is 30.4 meter. We continue with question 19. The diagram below shows the horizontal forces on a 20 kilogram mass. If the mass starts from rest, means V0 equal to 0, how far, asking for displacement, how far or x, has it traveled in the horizontal direction after 3 seconds? So this is the given and asking for the displacement or x. So here the motion is regarding the x-axis. So we replace the y from the previous question by x. So x is equal x0 plus v0t plus half at squared. So here x0 is equal to 0 because start from rest, and v0 also is equal to 0 for the same reason. So that's the equation that we will work out here in this equation. In this question, x equal half at squared. The problem here is to define the acceleration. So how to calculate the acceleration? Look at the picture. Here we have two forces and we have the mass. So of course we need to apply Newton's second law, F equal to ma. So you arrange the equation, A will be equal to F over m. By looking at the picture we can tell that we have two opposite forces. That's why we subtract the values. 100 minus 70, which is equal to 20, and the answer is 1.5 meter per second square. So we take that value and we replace it in equation 1. So x is equal now to 6.75 meter. We continue. So an object of mass 36 kilogram is being pulled on a frictionless horizontal surface by means of two strings. So we have an object being pulled by two strings. One string is pulling forward with a force of 300 Newton but making an angle of 40 degrees. The other string is pulling backward with a force of 12 degrees only. 12 Newton. So what is the acceleration in this case? So we have two forces acting in an object and they are asking for the acceleration. So that's the picture here, 300 Newton making an angle with the horizontal and 12 Newton which is straight backward. So how to calculate the acceleration? According also using Newton's second law, A equal F over m. So the force here is equal to, we have two forces, 300, but here 300 is not straight. It's making an angle with the horizontal, so we need to multiply it by cosine the angle. 300 cosine 40 minus 12 minus because it's moving backward. Okay, so minus 12 divided by the mass, which is 36 in this case, and the answer is option A. Next, an object is being pulled on a horizontal surface with a force of 135 Newton. It's moving with the uniform velocity. Uniform velocity means you are using Newton's first law because no acceleration, so F net equal to 0. So, and asking for normal force. So we need to calculate the normal force. How to calculate the normal force? Here is the picture. Four forces acting on the body. 135 Newton, force of friction, force of gravity, and normal force. And that's what they are asking to find. So by applying Newton's first law on the x-axis, we can say that F net is equal to 0. Okay, that's respecting the x-axis. So here we have 135 minus the force of friction because it's backward equal to 0. So we can say that force of friction is equal to 135 Newton also. So we continue. What's the relation that connects the force of friction and the normal force? That's the end that they are asking to find. So normal force is equal to the force of friction divided by mu. So force of friction already found, 135 divided by mu, 0.5, and then the answer is 270 Newton. Here we have which of the following pairs of graphs show the displacement time and the velocity time of an object speeding up from rest. So if object is speeding up from rest, of course, the velocity time graph, we have a straight line going upward and the displacement is making a curve upward as well. So this is the correct answer. That picture is the correct one because the body is speeding up. Velocity is linear upward and displacement is curve going upward as well. Any other picture than that is wrong. Here we have another, we're approaching the end of the exam, the revision exam. A box of mass 2 kg is accelerated on an inclined plane as you see here, making 30 degrees. The coefficient of friction is equal to 0.35, so force of friction exists in this case. What's the magnitude and direction of the net force on the object? So as you can tell that the object, of course, is going down. It couldn't go upward. So we can cancel or get rid of option B and option D. Both of these are wrong. So we still have two options to choose from, either 3.86 or 15.7 Newton. So you can say here that the mass of the body is only 2 kilograms and force of friction exists. So the force that making the body moving downward is very small because force of friction exists and also making an angle. So of course it's not 15.7 Newton because it's a big number. So it's only 3.86 Newton downward. Here we have this question. The free body diagram below show two forces acting on one mass. Which equation of the following represent the vector sum of the force in a Newton? So here in this question, you need to calculate the forces on the x-axis, and they are asking for. So here we have two forces, 6 Newton and 4 Newton. So let's start with the 6 Newton. By projecting 6 Newton on the x-axis, we can say that we have a 6 cosine 40 because it's adjacent to the angle. So 6 cosine 30 is 6 cosine 40. So all options that don't have 6 cosine 40 are wrong. So we can get rid of this option here. Option 3 is wrong. We continue. So we have another force, but we need to define the angle. You can say here we have here is a, I will draw. Here there is a plane. There is a straight line, so it's 180 degree plus this angle. This angle we need to find or define it. So it's 60 degree. This one is 60 degree, and all of it is 90 degree because it's perpendicular. So 90 minus 60 equal to 30. So this angle here is 30. And remember, this one is 180 plus 30, so it's 210. And the correct answer is the first one. Here we are with the last question. An object of an unknown mass is initially at rest and dropped from a height h. It reached the ground with initial velocity of v1. So in the first case, here in this question, we have two scenarios. First scenario where the ball is dropped. Drop means there is no initial velocity, v0 equal to 0. In the second scenario, we are throwing the ball downward with initial velocity. Here, v1 is not equal to 0. And they're asking to compare both velocities when they reach the ground. Of course, v1 will not be equal to v2 because both velocities will reach the ground. Both balls will reach the ground with different velocities. Okay, so of course v1 will be different than v2. That's not the correct answer. Also in the question, they didn't mention if the velocity is double or quadruple. So we need to multiply the velocity by square root of 2, which is multiplying approximately by 1.4, and that's the correct answer. Yeah, I wish you luck for tomorrow morning. Tomorrow is the physics quiz for Tamkeen. I wish you all to get a full mark, inshallah. And see you in the next video.